Today, we're going to learn about PWM, or pulse width modulation. PWM is a technique used in electronics to control the average power delivered to a device by rapidly switching a signal between on and off. To understand PWM, imagine a switch turning a power supply fully on and fully off very quickly. Instead of changing the voltage continuously, PWM controls how long the switch stays on during each cycle. A PWM signal is made of repeated pulses. Each cycle contains an on period and an off period. The signal keeps repeating this pattern, often too quickly for the switching to be noticed directly. The amount of time the signal stays on is called the duty cycle. It is expressed as a percentage. A higher duty cycle means the signal spends more time on during each cycle. For example, at 25% duty cycle, the signal is on for 1/4 of each cycle and off for the other 3/4. This produces a relatively low average output. At 50% duty cycle, the signal is on for half of every cycle and off for the other half. The average output is therefore higher than it was at 25%. At 75% duty cycle, the signal remains on for most of each cycle. Because the ON time is longer, the average power delivered to a suitable load increases. PWM can control LED brightness by changing its duty cycle. The LED rapidly switches between on and off, and our eyes perceive the resulting average light level as different brightness. PWM is also commonly used to control DC motor power and speed. By changing the duty cycle, the average electrical power delivered to the motor can be changed efficiently while the switching frequency can remain fixed. So, PWM means pulse width modulation. The signal switches rapidly between on and off, while the duty cycle controls the on time proportion and therefore the average power delivered to the load. That simple principle is fundamental to modern electronics.